Now, does anybody remember what we do for these ones again? Room 4. So we use an inlate, yeah? I-N-L-A-T-E. Okay. Is there any inverse trig? No. Is there any logs? No. Is there any algebra? Yes. Yes, there is. Right. A. So we're saying u is x, aren't we? And what are we saying about the u dx then? Making sure I'm on the right path here. Yeah, so u dx as well. So u dx is 4. Room 4. Probably. Now 1. Yeah, what do we do then? We go to v is what? Secant squared x dx, okay? Now, what happens when we integrate both sides? Is there an integral of secant squared on your tables? It's not there, right? Go to the derivative section then. Is there a derivative of tan x? What is the derivative of tan x? So by that logic, room 4. By that logic, what we should do is we should what's it then? V is tan x, is it? Is that right? It's the reverse of differentiation. Okay, we all good so far. Now, what's the rule? V to u minus u to v, is it? Okay, so u to v is v to u, so uv minus v du. Now, what am I going to call this guy? I decide I'm going to call him A. Is that right? He's now called A. So A equals the following: u by v, which is x tan x, integral of, anybody? Tan x dx. Okay? Tan x dx. Now, do we have to go around another time here? Yeah. Why don't we just do that? Yeah, exactly. So, there is, on your log tables, there is an integral for that, isn't there? So what's the integral? ln, two vertical lines, modulus secant x. Is that right? And that's x tan x. Okay. Now, and we're going to have to put plus c at the end, aren't we? Okay. Now, we can fix that up slightly, can't we? I'll show you a classic way we can fix this up. Would you agree that it's ln 1 over cos x? Would that make sense? Which is technically ln 1 minus ln cos x. And what is ln 1? 0. So this whole section here, it actually becomes minus ln cos x. And now when you do a minus by a minus, what you get? Plus. Everybody cool with that? Right, on to 15 now. 15. Okay, so what do we get this time, guys? 15. I think we're going to have to go around the circle this time, are we? In late. Okay. Any inverse trig? No. Any logs? No. Any algebra? No. Any trig? Yeah. U is cos 3x du dx is minus room for. Is anybody happy with minus sine 3x? And then integrate, differentiate the angle to get minus 3 sine 3x. We go. Okay. And what we're saying about the v? The v is what, guys? And dx, yeah. And then integrate both sides, and what do we get? V equals e to 2x, but then you have to half it, don't you? So half e to 2x. Okay. And then we're going to call this a. You are now called a. And a equals uv minus v du. Okay. And what we're going to say about a? uv. So we're going to say half e to 2x cos 3x minus the integral of v du, so it's a half e to 2x, and then it's minus 3 sine 3x. Okay? Now, just going to grab all this, just move it across for a minute. Okay? Now, if you're wondering where my targeting is going, I'm going to target it like this. I'm going to target the minus. I'm going to target the half. I'm going to target the minus 3. I'm going to combine them. And what am I going to combine them into? Can anybody tell me? Plus 3 over 2 on the outsides. E to 2x sine 3x. Okay? Now, unfortunately for us, it hasn't made things any better. Okay? What we're noticing is this is just as complicated as our original. So I'm going to call this whole thing B. Is everybody happy on calling that B? Okay. So B is going to require its own system for working. So there's going to be a U value and a V value for B. Okay. So the U value is going to be sine 3x. The U dx value is going to be minus 3 cos 3x, yeah? What's the v going to be? Oh, so just a plus, isn't it? And then what's the other one going to be? E to 2x dx, yeah? And then it's going to be integrate both sides. V equals a half e to the 2x. Is that alright? Now, here we go. What we're going to do is the following. We are going to do B is uv minus the integral of v du, yeah? So what's uv this time? Half e to 2x sine 3x minus the integral of v du, so it's going to be a half e to 2x, and then du dx 3 cos 3x. Okay. Now guys, if you look at our target in here, do you see the half and the 3? What are we going to do with them? Huh? Bring it out, so to speak, yeah? So 3 over 2 on the outside. Three over 2 on the outside, okay? Now what can I say this thing's called? This whole thing is A. It's actually A again. Okay? So does everybody see what I'm going to do with my B up here now? See that 3 over 2? I'm going to leave that 3 over 2 alone. And I'm going to sub out everything for b here. So it's going to be 3 over 2 times a half e to 2x sine 3x. And this whole thing is 3 over 2a. Now we're going to multiply all this out. And hopefully we're on our way to winning here. So a equals a half e to 2x cos 3x. 3 halves by a half is 3 quarters e to 2x sine 3x. And then 3 over 2 by another 3 over 2 is minus 9 over 4a. Now see that minus 9 over 4a, what am I going to do with it? I'm going to send it over to join the other a, which is technically 4 over 4a. Add them together, 13 over 4a, 13 over 4a basically equals this part here. Okay, now I'm looking at this and what I'm thinking is if I turn them all to quarters it'd be easier, wouldn't it? So see that half, I'm going to turn that to 2 over 4. So I'm going to get rid of the half, I'm going to turn that to 2 over 4. After I do that, all the 4's are going to disappear. And then I'm going to divide both sides by 13. And then, after doing all that, I'm going to check if there's a C value required. There is. And I'm done.